So in this video, we're going to look at how to evaluate recursive functions. So there's going to be a couple techniques we'll look at. One's called the bottom-up technique, and that's our first one. The second one's going to be the top-down technique. The bottom-up technique is probably the easiest one to follow, but it's sometimes the hardest to actually use. So we'll go through it and compare it to the top-down technique. When we call the calculate for function, well, we go over here, and if we put in 4 is not less than or equal to 0, so we're not going to do this. So we'd have to go down and do the else, which calls the recursion again. Now that seems like a lot of work to do, so let's actually start at the base case and work backwards. We know that if the input is 0, what this function is going to return, and that's going to be the number 0. Now let's figure out what calculate 1 is. If we put in 1 as an input, 1 is not less than or equal to 0, so we do the recursion, and it says we're going to return a, which is 1, minus calculate, which I'm going to abbreviate as c, of a minus 1, so c of 0. And remember, we know c of 0 is 0, so this is just 1 minus 0, which is 1. Now if we do calculate of 2, once again, we don't hit the base case, we return 2 minus calculate of 2 minus 1, which is 1. And we know that calculate of 1 was 1 from the previous line, so we have 2 minus 1, which equals 1 again. For calculate 3, once again we don't hit the base case, so we're going to return 3 minus calculate of 2. Remember that calculate of 2 was the value 1, so we're going to do 3 minus 1, which is 2. And then for calculate of 4, we're going to return 4 minus calculate of 3. And remember that calculate of 3 was the number 2, so 4 minus 2 is 2. So we got to the answer for what calculate of 4 was by figuring out what the base case values were. Another way to go through this, and this is the technique that I usually use, is what's called making an evaluation tree. So the goal, once again, is to figure out what calculate of 4 is. So once again, I'm abbreviating calculate as C. I don't hit the base case, but what it tells me I'm supposed to do is do my A value minus the calculate function on 1 less than A, so that's 3. So what's calculate of 3? Well, that's our new A value, 3, minus calculate 1 less than our A value, 2. Well, what's calculate of 2? That's 2 minus calculate 1 less than our current A value. And what's calculate of 1? That's 1 minus calculate of 1 less than our current A value. Now what's nice about calculate of 0 is that hits our base case, and calculate of 0 is just the number 0. So now we can backtrack and figure out what our original value was. 1 minus this 0 is the number 1. So this 1 comes back up here. 2 minus 1 is 1, which comes all the way back here. 3 minus 1 is 2, which goes all the way back up here. And 4 minus 2 is the value 2, which goes all the way back up here. And we have our answer for what calculate of 4 is. So often this is the way that I set it up, but it's functionally equivalent to the bottom-up technique. So let's look at some code that has some issues. So if we had this recursive function, you'll see that mayhem is calling mayhem, so it is recursive. What would happen if we did mayhem of 5? Well, mayhem of 5 would call mayhem of 4, which would call mayhem of 3, which would call mayhem of 2, and at some point you'd have to call all state. At some point in the future that joke won't make any sense, but that's okay. For now it's fine. So this goes on forever, and by forever I mean until Java gets mad at you and says you've run out of memory, because you can't do this forever. So this is something called infinite recursion and causes a stack overflow exception. That's the exact error you would get in Java. Essentially you have these new functions being called over and over again, and at some point Java runs out of memory and overflows the function stack. So this is bad. It is missing what's called the base case. So if we look at a version of mayhem that has the base case, we'll see if this has any issues. If we call mayhem 2 with -1, so notice I changed the name of it because it's a different function. If I call it with -1, oh, sorry about that. Well, it doesn't hit the base case, so it returns 2 plus mayhem of 1 less than the current input. Oh, I'm sorry. Yeah, -2, right? Because my input had been -1. So I'm calling the function now with an input of -2, which once again misses the base case and is going to do 2 plus mayhem of -3. And unfortunately, this is going to go for a really long time because this base case 0 is just going down, it seems like forever. Now, for those of you who remember from way back in, like, I think it's Unit 2, maybe it's Unit 1, Unit 2. Actually, I don't remember. One of the units first semester. Um, if you go down far enough in the negative integers, at some point you will wrap around to the positive integers. So theoretically, if we had infinite amounts of memory, not infinite, but a lot, we could eventually get it so that it wraps around and eventually would hit the base case. Um, Practically, that won't happen. Usually after about 255 iterations of recursion, Java says this is ridiculous and gives up. So this one won't work. If you said that this had a Stack Overflow exception, you're right. Um, and theoretically, if this was just like on an infinite computer with infinite memory, this would be called infinite recursion, which is why I call this to infinity and beyond. So the moral of the story here is watch out for base cases. It's very important that you hit them. If you do not hit them, your code will crash with a Stack Overflow exception.